Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. It is 4.1, Day 2, Exponential Decay. If you remember, our last lesson on 4.1 was exponential growth. Now we're going to look at the graphs going the opposite direction, okay? The exponential function is y equals a times b raised to the x power, where a is the initial amount, just like before, and b is the base, just like before. All right. So we need to evaluate the following exponential functions for the given values. For problem number 1, my initial amount is 2, my base is going to be 1/2, and I need to evaluate that for x equaling 2. So what I'm going to do is I'm going to go ahead and rewrite my problem, but I'm going to replace x with 2. You can type that straight through in your calculator. If you do, you end up with 0.5, but another way to look at this is if I take 1/2 and raise it to the second power, I will end up with 2 times 1 over 4. 2 times 1 over 4 would equal 0.5. Again, you could have typed that straight in your calculator, but you can also do it by hand as well. On to problem number 2, y equals 3 times 1 over 4 raised to the x power. If I put 0 in for x, y equals 3 times 1 over 4 raised to the 0 power. If I raise anything to the 0 power, it's like it never happened. So that 1 over 4 would actually turn into 1. So anytime I raise something to the 0 power, it turns that into 1. Or act like it never happened, y equals 3. Okay. Problem number 3, I have y equals 2 times 1 over 3 raised to the negative 2 power is what I'm going to have to do here. So y equals 2 times 1 over 3 raised to the negative 2 power. If I go ahead and type that straight through in my calculator, what I'm going to end up with is y equals 18. Okay. The negative, what it really does is it flips my fraction, and then I would square it, so that 1/3 would actually turn into a 3. Then I would square it, would turn into 9. 2 times 9 would get me 18. All right. That should be pretty much review from what we did in the last unit. The only difference is, not the last unit, I'm sorry, the last note sheet we did. The only difference is, instead of using whole numbers inside of the parentheses for my base, I have fractions. And that is how I can tell whether it is going to be decay or growth. If I have a fraction inside of my parentheses for my base, then it will be decay. If I have a whole number, then it will be growth. So now on to some graphs, just like we did in our last section. We need to go ahead and replace all of the x's with all of the x's here. So the first one we're going to use is -1. If I replace the x up here with -1, then I'm going to end up with, it would be 16. How I'd type that straight through my calculator, I would use 8 parenthesis 1/2 raised to the 1/2. If I type that straight through my calculator, I'll end up with 16. For the second one, if I have 0, it would be y equals 8 times 1/2 raised to the 0 power, which would get me 8, because remember, if I raise anything to the 0 power, it's just 1, or it's like it never existed. If I raise it to the first power, I'd have y equals 8 times 1/2 to the first. That would end up getting me 4. To the second power, I think you guys understand how we're doing this by now, typing into our calculator. We'll end up with 2, and if I raise it to the third power, I would end up with 1. Now, what do I need to do here is to go ahead and graph that. So I'm going to go -1, positive 16. They cross perfectly right here. 0, 8 is perfectly crossing there. 1, 4, 2, 2. And then 3, 1. 1's about half of that, because if you notice on our y-axis, it's going up by 2's. So what I'm going to do here then is just go ahead and connect my points just like I did in the last section. Make sure that I get close to 0, but I don't want to touch 0. Okay? So my domain, just like it was in the last section, is going to be all real, because this graph goes on forever and ever and ever in both directions. So I have all of the x's are possible in this graph. My domain talks about the x's, so it's all real, or double bar r. We have talked about that in the past. My range is all of my possible y values. Well, because of this area right here where I do not touch 0, but I get extremely, extremely close to 0, that means that my y's will always be positive, means they'll always be greater than 0, so my range would be y is greater than 0. All right? On to the second problem. I have 9 times 1/3 raised to all these different powers. So if I raise it to the negative first power, I would end up with 27. Remember to do that. I'm going to use y equals 9 times 1/3 to the negative first. That would be 27. Y equals 9 times 1/3 to the 0 power. Remember what happens with the 0 power? It turns the 1/3 into 1, which 9 times 1 would just be 9. The first power, I would take 9 times 1/3. Well, 1/3 to the first power would just be 1/3. So 9 times 1/3 would end up getting me 3. 9 times 1/3 to the second power. 1/3 to the second power would be 1/9. 9 times 1/9 would get me 1. 1/3 to the third power would be 1/27. 9 times 1/27 would get me 1/3. Again, you can just type that straight through in your calculator. If you are struggling with how to type that in your calculator, please let me know and I will help you with it. Okay? So go to -1, -27 would be right about here. Notice that each one of these y tick marks is going up by 3. 0, 9, 1, 3, 2, 1 would be 1/3 of one of those tick marks. So I'm going to put it right on top of that little tick mark above the 2. And 1/3 I'm going to put literally over top of that tick mark. Just doing the best we can there. We do not want to touch 0. And there we go. Remember that my domain then would be double bar R because all of the x values on this graph are possible. And my range, again, I'm getting close to 0, but I'll never touch 0, so y is greater than 0. On to the back. We need a graph. Y equals 16 times 1/4 raised to our different powers. Again, I'm just going to take -1, put it in for x. If I do that, type it through my calculator, I end up with 64. If I put 0 in for x, 1/4 raised to the 0 power would be 1. 16 times 1 is 16. If I put 1 in for x, 1/4 raised to the first power is 1/4. 16 times 1/4 would get me 4. It's the same thing as 16 divided by 4. 1/4 raised to the second power is going to get me 1/16. Well, 16 times 1/16 is 1. If I take 3, put it in for x, then I have 1/4 raised to the third power, which is 1/64. 16 times 1/64 would get me 1/4. Okay? So -164 is going to be here. 0, 16. 1, 4. 2, 1. Again, I'm going to do the same idea I just did in the last problem, where I'm just going to guesstimate and be pretty close to where those points are going to be. Need to connect all my points. I want to get close to 0, never touch it. And we're good there. Again, all x's would be possible in this graph. My y's never touch 0, and they're never below 0, so y is greater than 0. All right. All right, now that we are done with our graphs, we're going to decide if the following equations represent exponential growth or exponential decay. If you remember from the beginning of this lesson, I talked about the difference between exponential growth and exponential decay. It all stems from our b value, our base, what's inside the parentheses. If what is inside of the parentheses is less than 1, so if my b is less than 1, it will be exponential decay. All right. If my b is greater than 1, it will be exponential growth. So the easiest way to figure that out, especially if it's a fraction like problem number 7, if I have a fraction, I'm just going to take 1 divided by 2 in my calculator. Well, 1 divided by 2 is going to be 0.5. Is 0.5 greater than 1 or less than 1? Okay. Well, it's less than 1, so it's going to be a decay problem. 2, is 2 greater than 1 or less than 1? It's greater than 1, so I have a growth problem. 3 is greater than 1, so I have a growth problem. See, as you can tell, I'm only looking at what is inside the parentheses. That's it. That's all I have to worry about to decide whether it's growth or decay. 0.8, is that greater or less than 1? Well, it is less than 1, so I have a decay problem. And 11 is 1.3. 1.3 is larger than 1, so I have a growth problem. All right? That is the end of our lesson. The most important things to remember here is that my a value in my exponential function is my initial amount. My b value is the base. To evaluate functions for given values, all we have to do is take the number that it gives us and plug it in for our x. To graph, I just need to fill out my table, which all I have to do in that situation as well is just take the x value, plug it in for the x in our problem, and I'll get my different numbers. Then remember the difference between growth and decay. If my b value is less than 1, it will be decay. If my b value is 1 or greater, then it will be growth. All right? Remember, if you have any questions on this assignment or the assignment before, please make sure you come and see me. Don't sit around confused. Thank you very much for watching the video, and have a great day.